life.
All right. Oh, bollocks. All right, my screensaver decides to kick in all the time. I blame Ubuntu or something to do with its laptop settings. Hi, my name is Carsten, or others know me as Rasta. I've written a little bit of code for Linux over the years. Some people may use it, some people may not. But one thing I'm absolute freak about is doing things right, doing them well, and doing them efficiently. So I'm going to talk about the state of our desktops on Linux at the moment and why they're particularly overweight and what can be done about it, how you can improve code for your desktop, or how I've done it at least. So let's start with some facts. The average PC today that people buy after doing some research from Gartner is about $1,200 for your average PC. Who here thinks that today's average PC is perfectly capable of running, let's say, the average Linux desktop, GNOME and KDE, perfectly well without any problems, without getting a high-end PC? Okay, that looks about half of you think that. How many people here think that you need to get a fairly high-end machine to run a modern Linux desktop like GNOME and KDE? Okay, about another half. What is the slowest machine that you've run a current modern Linux desktop? A 500 megahertz P3 box or less? All right. 333. Did you actually have to tweak it very much? Or did you just run everything out of the box and you're perfectly happy with its performance? Okay, all right. So, they actually want both. And it's a trade-off. But now going back to that, remember, we live in the West here, and we are really, really spoilt for being able to get access to hardware fairly cheaply relative to what we can earn or afford. The more recent project that's pretty popular and everyone knows about it, I think, the OLPC. It's about $190 at the moment. The aim is to be $190. That's $190 Australian, by the way, these values. And that's a 366 megahertz box with 128 meg of RAM. Who here actually uses a desktop that's not far from that kind of configuration? All right, not many. Well, the average income in Australia is about $43,600, I believe, from the census figures. That means every year you can buy 36 average PCs. Well, if you don't pay any tax, that is, in this country. That's at $1,210 a pop. The average income in China is $1,635, and let me tell you, relative to a lot of other places, they're wealthy. That's 1.35 average modern PCs for that they can afford. That means the average PC for them is costing $32,000. Who here would be happy if they had to spend $32,000 on a PC to run a Linux desktop? Oh, I see a lot of hands went up from that. The reason the older PC thing exists because even for them, the average an older PC at its current price costs about $5,000 in relative terms to them. If you had to spend $5,000 to get a PC, would you do it? Yep, okay, we've got more of you. But that's an incredibly limited machine. Go back 2 slides. Now think about, put those together on current modern software. So that means you're going to have a lot of unhappy users because if you went and spent out that money, it couldn't run a modern Linux desktop. They had to customize software to run on that. I remember when I started using Linux, and that was a Pentium 120 with 32 meg of RAM, and I coded Enlightenment on that from the ground up. I did all my development on it, compiling, you name it, and I was quite happy. That worked very well. It's amazing that these days with machines infinitely faster, they are not actually infinitely faster at all. They're slower. So spending $32,000 to get a modern desktop to run is really ridiculous if you put it in terms that you would understand. Now imagine you were someone in a nation even poorer than China, where that would not be equivalent of $32,000, it may be the equivalent of $100,000 or $200,000 to buy a PC. It matters. To these people it matters, but unfortunately they're not the ones writing the software. We are. So it really should be in our ballpark to consider these people. They are important. Now I did a few comparisons recently. As I said, I'm a performance freak. Well, we actually, huh? Yeah, we have really strange versioning. We've done 0.16.999 is the version just before E17 will be released, and then we have in a subversion below that every time we do a snapshot. So.
Does it hit E17 when a floating point does okay?
Yes, I'm just kidding. Well, it'll become 0.17 when we get there. I actually just don't see a point of doing 1.0. Who cares? That's just the next number up. So I compare them. Now, this is the... Can you actually read that? Yep? Okay, good. This is the amount of memory that a system as a whole, this particularly was on top of an Ubuntu Edge box. In fact, I did it on my laptop here, which is now currently running. That when the machine boots, accounting for just RSS pages. Now, we can all sit here and argue. If you want to sit here and argue about exact memory usage, we can do that till the cows come home. These are relatively rough figures. But if you wanted to talk details, we can always do that later. But this is just in RSS pages. This is pages mapped in for processes to run. This is not I/O, cache. It is not swap or anything. It's just memory. This box has 2 gig of RAM, so I wasn't swapping. And that's 51 meg of my memory gone, like used up just to get a box up to a prompt, a text console prompt. That's pretty fat. But let's, for now, just not worry about this, because that's your base system. Let's worry about desktops and later. But as you can see here, relatively speaking, E on login, 76 meg. XFCE, 76, pretty good. GNOME, 75, yeah, not too bad. And KDE, 102. A little bit fatter. But it actually does matter. Philo access, this will be the amount in cache that you've actually managed to load off disk, because disk is slow, and you have to load it into memory, so it'll be a performance issue. And if you can't cache it, you will have to be continuously fetching it off disk. So in terms of disk usage, down below here, you can see that it's about 90 meg when you start, 103 for Enlightenment, 103 for XFCE, 102 for GNOME, and about 144 for KDE. But this, by the way, this is only to the login manager. This is like, I'm going to log into X now. You haven't actually started a desktop yet. These are the respective login managers. And for E, I was using Entrance, which is a little bit crufty and nasty, but it can do with improvements. And then it was GDM for XFCE and GNOME and KDM for KDE. Now, this is just the relative numbers based to it. Now you can see that's about 25 meg for the login managers and 51 for KDE. So login managers, GDM was the same one way or the other. And Entrance was about the same too, within a meg here or there. And the amount of files accessed as well, you can see below there. Oh, whoops. No, sorry. I'm really sorry, I didn't read the one I was writing. They were the top line numbers, and this is relative. This is the numbers I really want. Now, the first line you see, that's base login, 25. Now, your next line, that is immediately after you've logged in. Well, with Enlightenment, we used an extra 400K of RAM to log you in. That's including all the fancy graphics and everything else, and I'll do that a little bit later so you can see what happens. XFCE has jumped up to 48 meg, GNOME up to 61, and KDE up to 67. In terms of amount of extra more disk that we've had to access after that, we've got about 18 meg for Enlightenment. I can tell you exactly why it's relatively inefficient there, and I really do plan on fixing that. XFCE is actually about 83 meg, GNOME about 74, and KDE about 115. The real fun then comes, we decided to launch Firefox, because we can all run around and say, well, maybe we should see what it does when you start running programs, because that's what people do. And one of the most popular things is a web browser these days. So I chose Firefox. And 47 meg of my RAM is used there. Admittedly, Firefox is using the lion's share there. 70 for XFCE, 83 for GNOME, and 90 for KDE. As you can see, that's a fair bit of memory. If we're talking about something like the OLPC, which has 128, we're using most of it. In fact, we're using more memory than it has as a total. If we go back there, we're already into swap, just to browse the web on a standard desktop. That means we need no file cache at all. So now, visually, if you want to have a look at that, relatively speaking, when you log in, that the desktops tend to use a lot of resources. And eventually, the purple bar at the top, enlightenment, is actually very small. Now, we get to be small and be really fancy with eye candy, and we have a few handicaps, like all our graphics are stored in client memory space. They're not stored in the video card, in X-server memory. They're all in client space. So we pay the price for all of it in the client currently, and that's a matter of being able to work on anything irrespective of display system. And the relative disk I/O usage, which is a factor, because you do have to load that data from disk or keep it cached or both. You can see there again. Now, of course, these also impact in speed. So how long does it take me to go? I typed in my login name and password, and I want to actually do something. Well, as you can see, to the console, I assume that's pretty zero. It doesn't take any time. To log in on a fresh machine just after you boot it, 3.3 seconds for E. XFCE 9.5, GNOME 13.7, KDE 16.4. This is, remember, on a 1.83 gigahertz dual cores Core 2 Duo box. This is not a 336 meg geode OLPC box. I did actually do some testing. I have some numbers here in a spreadsheet where I pretended my box was really slow, and I basically put it down to 1 gigahertz and set the throttling up to 87%. And these numbers were in the multiple minutes to log in for GNOME and KDE and even XFCE. So, but then cached, once it's actually managed to load data off disk, the numbers, of course, improve for everybody. Numbers improve, but as you can see, less than a second for enlightenment, which makes it fairly efficient. So the question is, well, okay, you've got something that's really fast and efficient, and that's all great, you know, hooray! But how do we get there? How do we make things efficient? Well, to make things efficient, you actually have to, when writing your code, care about somebody who doesn't have what you have. You're a developer, you're probably having some overly powerful, beefy box. Even if it isn't the beefiest thing in the market, it's much beefier than a lot of people can afford in most of the world. Actually do statistics on your code, analyze it, think about it, you know, go through and do memory analysis, use tools, do profiling on your code, pay attention. Going to disk or doing system calls is expensive. Forking processes and executing things is extremely expensive. Don't do it unless you have to. And then look at what other techniques people have used in other places. Think carefully. And here I'm just going to go through a few of the things I have used here. One, put timing code in your code. That is an output currently from E17 when it starts. It basically spews that out to standard output, and that is what basically lets me know how long it takes to do things. And I use that actually to optimize the code. That's a oldish dump from a while back. And it just lets me know, you know, this bit here took this much time, and I should check into that because, you know, 0.42 seconds, that's way too long to do that, for example. So by doing this analysis, I actually managed to find a few problems. I removed a few useless X round trips, and I shaved off about half a second. I removed pointless init code, which was just had been there ever since, and it's like, oh yeah, I really don't need that. And I removed it. Oh yeah, and I implemented something called pre-caching, which is a bit of fun where most of the time when you log in, you spend a lot of time hunting for disk, looking for files, especially with these wonderful standards from freedesktop.org for all our .desktop files. When you have about 1,000 or 2,000 files you have to actually load and parse on login, that's a lot of disk seeking, a lot of hunting. If you do it on demand, you're going to spend a lot of time in wait states waiting on disk I/O to come back to you. If this is already sitting in cache, it is significantly faster. So I actually added a thing that figures out all the files you access on login and basically forks off all these things in the background to do it for you before you need it. So it kind of precedes the kernel disk cache. Oh yeah, and that's exactly what I was talking about. The fun bit about there is actually a bit of evil LD preload I did that basically overrode system calls. Actually, the original I did was overloading open, read, write, stat, open dir, etc. But for some reason, Ubuntu's libcs do not let you LD preload and overwrite those. It cannot find the symbols, and I'm not sure why.
Talk to Peter Miller about that. Talk to Peter Miller about that issue.
Okay, it is an issue?
He knows about that, and
He doesn't what?
He doesn't like Uli Drepper.
Oh, okay, yeah. Yeah, but it has actually worked before in previous libcs, like ages ago, and I thought, yes, I'm going to do it again. And it's like, where are my symbols? Where'd they go? And I'm hunting around. Oh, yeah. I've lost. The gaffer tape's not working. Sorry. But either way, this was a mechanism which allowed me to basically create statistics, find out everything I was doing on boot, when, where, what, how, log it, and then repeat it and run it again on login, but do it ahead of time. So while the main program's starting up, something in the background's going preceding cache and snuffing it all in. And it really did shave things down. We about doubled our login time as a result of that.
I personally got 10 at 0.3 second startups.
Yeah, it'll depend on your system, how many files you have, you know, how fast your box is, how fast your disk is. But these are numbers here, but they did work.
And I gather more cores helps with that.
Yes, it does, because actually the way this works is it literally forks off one child process per file that it has to do. But the reason being is that, here's the reason, there is no way to know where on disk the extents are to minimize seeking, because you don't know where that is. So what I do is I actually found higher performance by doing that, throwing it like as much as the kernel as I could in one big lump, as quickly as I could in parallel. The kernel would basically chunk it all together, and it would actually be faster, because it would try and do the file ops if they were within the sequential segments, or they didn't have to seek, the kernel would reorder it. It would actually be faster. Try it. It does actually work. Yes, the expensive forking was less than the I/O seek time, that's why. Or the I/O seek time overhead.
Did you try that on a little box?
A little box? I don't have an old PC box, but I have tried it on my 1 gigahertz Pentium M, low volt, whatever. And that is actually very slow, relatively speaking. And it works perfectly well there too. It does get a speed up. So,
I might jump in on this one. I constantly do testing on a 100 megahertz speed Pentium with 64 megabytes per RAM or something like that. And it works reasonably well there too.
Yeah, but as I'm saying, this is a hack around the fact that I know what the hardware's like, I know what it does. I'm getting around the fact the kernel lets me not know enough information in a sane way to be able to do this properly. What I would like to know is what blocks I access, where they exist, is there a seek in between these blocks, and just tell the kernel, these blocks, load them now in a predefined order to minimize seek. But I can't do that, so, well, unless someone knows a better way of doing it, without having to be root. Okay, all right, but that worked for me. Anyway, other things you can use to optimize is memprof. It's amazing how few people know what this thing is. That's probably because it was unmaintained for a long time, but recently it's come back into maintenance. But it tells you a hell of a lot of details of where your memory is being used, exactly what is using it, how many times it's being allocated, it even finds leaks. It's not good at finding leaks, but it does. I'd rather use Valgrind to find a real leak. But it's really good at finding pointless memory allocations. So one really good example here was created this configuration front end, which basically would guarantee you would always get a string. So if you had an element from your configuration that said, you know, some field, and it would have a string, that would always guarantee to give you a valid pointer, so you would never segfault, accidentally have a null pointer, because there was always something there. Unfortunately, there were a lot of fields in configuration values that were empty strings. Instead of giving you a null, it gave you an empty string, a 0 byte string or 1 byte allocation for it. And I had thousands of these through configuration nodes. And doing analysis on this, I found that, and I went, wow, that's a lot. It actually gave way to a string sharing subsystem, which is basically a string tokenizer, which you can stick a string once in it, and then after that, if you stick the string in again, you'll just get the same token back and it'll just ref count it. That saved a lot of allocations. It definitely cleaned things up, and it actually gave a few little speed ups. So it's actually a lot cleaner. But this is only for strings you're not going to modify later. If you modify, you've got to remove it and add it back in. Oh yeah, and memprof just became alive again recently. So, and then actually, I started looking at memory usage. Can you guys actually read that? Probably not. Well, I'll read it out to you because it's hard for me. But anyway, this is MetaCity. This is the window manager for GNOME. Remember, GNOME doesn't just run a window manager. It runs a panel, runs a file manager for your Icons desktop, runs about 20 different services. Okay, not 20, but a whole bunch of things that are spawned up on login. This is merely one of them, and I'm trying to compare oranges against oranges, like window managers versus window managers. MetaCity, startup, it actually allocates about 40,000 bits of memory, 40,000 allocations, and that totals about 2.6 meg of RAM. And that's just for the window manager. That's only one component of GNOME. Fluxbox, which is a window manager, people love to run around and tell you it's a minimalist window manager, it's so fast and small. Well, let's see, 39,000 allocations across about 2.37 or 2.4 meg of RAM, give or take. That's a minimalist window manager, really. And here's E17, 2.6 meg of RAM and only 13,000 allocations. The difference is you get your whole panel, launcher, your desktop switcher, modules, et cetera, all there for free within that allocation. That comes for free. That's not extra on top of it, unlike the others. So when people run around like to say things are minimalist, E17 is definitely in the minimalist bandwagon, especially when it comes to bang for your buck. And that's thanks to actually having spent time doing profiling like this. By the way, if you actually could read that, and I do have images on my website here, you can look in detail, about 80% or so of Enlightenment's allocations are only images or font data. They're not actually data structures, they're just raw pixels. As I said, they're not put in the X server, they're kept locally. So we suffer from having to do that, but that's within that memory allocation there. Unlike the others, which don't actually do any of that. They actually have no desktop backgrounds and no little fancy icons displaying and blah, blah, blah. They're fairly minimalist. So a few things you might want to know when trying to be efficient. Remember, executing a process is heavy. If you don't believe me, just run strace next time and look at all the things on your system it attempts to stat, open, map, et cetera, et cetera, et cetera. That's every time you execute something. No, fork does a copy and write. Fork does not do that. Exec is different. Exec is nasty. Fork is nowhere near as nasty as exec. Fork just makes a copy of a current process. Exec is really nasty. Huh? In comparison. But, yeah. So if you've got a choice of doing it in line or doing just a fork child or executing something, you would do it in line if you can do that. Forking is better. A thread is more minimalist than a fork, of course. But execing something is pretty evil. You'd better have a very good reason for doing it. It is actually heavy. And remember, every time you do spawn a new process, like anything that uses X, it will make yet another connection to the X server. And that will require negotiating things, going back and forth, building internal tables, finding out things about your display every time you run another X program. So that will require a lot of round-trip requests. So executing another GUI program has actually got a lot of latency in it. So if you can avoid it, it's not a bad idea. Also remember that every time they build their own internal information, like what depth the X server has, what fonts are available, GTK used to do quite a big listing of that. But they don't share this data. Each process builds its own copy of this information. It's private. There are moves to fix this within font config to actually create mapped memory map files where you would share that across. The first guy in basically fills it up, and then everyone adds to it, but it's shared. But a lot of it still is specific per process. And if you want to just add simple features to something, admittedly, if you load a .so, a loadable object, and it does nasty things like it crashes, it will crash your process. But as long as it's very small and simple, it can be kept stable. And it's a good way to extend something you have with very, very low overhead, because the parent process that is going to be loading these modules has already done all the init work for it already. So loading the modules is very low overhead compared to executing another process, if you add all of that up. So yeah, don't execute something unless you need to. Share resources wherever you can, because loading things multiple times, decoding them, decoding them multiple times is really bad. Decoding them is multiple times is really bad. The stampeding herd, where basically you have a gazillion things trying to connect to X, or when you log in and hammer it for information, all trying to do the same thing, is fairly bad for performance. Pre-caching data is a good idea, and we could do with better mechanisms from the kernel than that currently. You can talk to me later. And profile your code, profile your memory, profile everything. It matters, it makes a difference, and know your code. If you don't know what it's doing, you probably won't know if it's efficient or not, and how much resources it really is using, and if it should be using them. You should know it, so if it's allocating a line for memory, that is required, not just there for fun, because someone decided to allocate it, keep a pointer, and not do anything with it later. So now I'm going to get on to the bling part of my talk, which involves pretty stuff, or talking about it. So what is this thing we call enlightenment? Who here does not know what it is? Wow, damn. All right, I have to get rid of this part of my desktop. I'll just try my talk. All right, but the new version is a minimalist desktop shell. It's meant to add everything that is not applications that you need to run your desktop. It is actually very fast and lean. No, it is not the size of Ion or rat poison, but then again, it has a little bit more functionality. Well, okay, that is if you are happy with Ion 3 or rat poison's functionality. I'm not entirely sure that what you're doing here in this room. But if you actually want something more Windows-like, Windows, mouse, pointers, play with that, this is definitely lean and mean. It's able to actually look pretty with no high-end hardware. And when I'm going to show you a bit later, I'm not using a 3D composite, I'm not using GL. This happens to have an NVIDIA chipset, but it would work just as well on a dumb frame buffer with some low-end, S3 card, and it would not make a difference. Currently, we're finishing off all the basics. And that you would need to manage your desktop, configure things, even browse your files and manage them. There's actually a file manager built in these days. And most people say, why are you putting a file manager in a window manager? The reason is that we need a file selector anyway, and if you need a file selector, you may as well have a file manager. It's the same thing. And in future, we're going to move to using the higher end hardware, but it's always going to be optional, and you will not have to pay the price of needing it to run anything. We are following standards. We use like a chunk of the free desktop.org standards. Unfortunately, sometimes that's painful. David here actually implemented a whole bunch of the .desktop reading stuff.
It scares Rasta.
I don't like it. It's very nasty with the files spread all over the place. We've got a lot of attention to detail and optimizations. It is extensible via modules, so if you don't like something or want to add something, you can just write a tiny little module to add functionality. These things are just loaded in, much like a kernel module. Loaded in and execute, they can hook themselves in anywhere and do whatever they want. It's very visually configurable, although not a lot is available yet because we haven't really encouraged people to write themes, but they are already, despite that. Anything can be animated if you want it, and that's actually useful for doing things like getting attention to something when someone should pay attention to it. Because often, something happens and nobody knows, ooh, there's something important here. If you animate, it's a way of getting attention. It should not be overused. It should be used carefully with pizzazz and with forethought, not just let's animate everything we can. But it can do it. It's a mechanism, not necessarily a requirement that you have to animate everything. It can use multiple rendering engines. We actually render in software by default. We do not use any graphics acceleration to do our rendering. But we can use Xrender to do it, and I'll show you a bit of demonstration later about how wonderfully fast Xrender is these days. And we can all use OpenGL. And all the backends are very much multimedia oriented. Enlightenment started from me looking at games on my Amiga going, why can my 7 megahertz Amiga do fancy user interfaces and this 300 megahertz Ultra Spark thing here can barely do 2 bevels in a box. So it started off being inspired by media and games, and it still is very much built on top of that. The graphics engine is called Evis. It is actually used for much more than just Enlightenment at the moment. It's used in several places outside of it. It is just a shared library on its own. It's just a big state engine. It means you don't actually draw things, you define how you basically define a scene graph. You say, this is what things look like. This is here, this is somewhere else. These are all located in certain areas, and it deals with how to display that, render it, and change it when the state changes. So all you do later is say, this has changed to move here, become this size, this file is backed, this color. It does, redraw optimizations for you, so you don't need to know or care. And it also means it abstracts what the underlying display mechanism is, and I've got a nice demonstration of that later which I actually use for my home videos to play all my DVDs, because in Japan they don't have DVD players that can play multiple regions, because the Japanese just don't watch anything except Japanese DVDs, because they don't understand other languages mostly. So it's very hard to find off-the-shelf devices that will play my DVDs, so I resorted to building my own software to get around that and make myself happy. So we have a fair few display engines. The software engine is highly optimized. In fact, if you've got a multi-core box, it actually has an SLI implementation in it, where it actually fork off threads per CPU and it'll parallel render everything it can, much like GPU SLI stuff. So it goes, ooh, resources, fun, and decides to use them all. It will do that automatically in the background. You can actually compile without that, but you do get speed ups from it. I did actually some experiment with different kinds of SLI, but the one I ended up doing is splitting into N regions, like top half, bottom half, for example, for 2. Odd line, even line ended up being actually slower, doing it that way. There is an X-render engine using that wonderfully fast thing called X-render, and that is meant to be a sarcastic statement. But it is actually the best mechanism for doing rendering in X, or should be, but it isn't. Thank you, our driver writers. OpenGL has pretty much full support at the moment. I fixed up the GL driver lately. But there are a few things GL is really horrid at when doing 2D and doing things like window managers, and there's a reason it isn't supported in the window manager right now, but all the graphics rendering underneath it can. I can go into gross detail in there, everyone will ask me later, but it is good, but in other ways not. It has a frame buffer engine, so if you decide you don't want to actually run an X server and you want to build a small little device with a dumb frame buffer, and you wish to display like a custom UI in it, well, do you know what? You can do all your development on your desktop in a window, and then with one line of code change, it's displaying in the frame buffer. Exactly the same, identical, no changes. You'll get exactly the same output. It does actually have a Qtopia engine. I wrote absolutely ages ago, and it works. And it also has a few other ones. It has a Cairo engine I half did, and I did some performance testing and found it was 25 times slower than our existing software engine. I decided that I didn't have that much more interest in continuing it at that point. There's a DirectFB engine, which is a little bit under-maintained, but it did work very well last time I checked. And a few things we're going to dig into back into the window manager. There's a lot of terminology. Everyone runs around about composite, X-composite. X-composite does not make windows transparent. Everyone keeps asking for them, and they say, oh, are you going to do things via X-composite? Doesn't that make it possible? No, it does not. X-composite does one thing and one thing only. It basically changes the rendering model for X. Instead of rendering directly to the front buffer, i.e. the frame buffer for a window, the rendering for a window is redirected to a pixmap, to a bunch of pixels off the screen that is now accessible. That means you can do something with it later, but that is all it does. It does nothing more than that. It does not provide fancy effects. Oops. It does not provide fancy effects. It only does that one thing. There's, in fact, another extension called X-damage, which will then give you events saying when a region of a window was drawn to. Now, you put these two things together, and you can say, well, something's writing to a pixmap, and now I'm getting events telling me when something wrote to it. Now I can copy a bit of that pixmap somewhere else onto the real screen, and that's how a compositor works. And how it copies that onto the real screen is where the fancy effects come in. Unfortunately, that bit of the pipeline, one of the key pieces, X-composite is another key piece, is not that great. That's often where X-render is used, and X-render does the alpha blending and scaling, blah, blah, blah. Or with XGL, they actually then use a new extension they added to OpenGL, which basically lets you create a texture directly from a pixmap and then use OpenGL and basically map the texture onto a polygon and blah, 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 blah. That's basically the one big trick that XGL has under its bonnet. So, but unfortunately, X-composite isn't the solution to all of this. In fact, X-render is a solution, and that's unfortunately the sore point or the chink in the armor at the moment. And the other problem is this uses absolutely huge amounts of video RAM. You need a lot of it to do it. I personally would suggest not having anything less than 128 meg of video RAM to do recompositing. It's very heavy on usage. And we can go into details exactly why, but trust me. So XRender is the key here, and that can take basically two pix maps and blend them, skew them, do all sorts of fancy 2D effects. So anything you see in OS X, Mac OS X, XRender can basically do for you. And it is intended to be able to do this with acceleration, et cetera, et cetera, et cetera. It is the right API to do it because it is an X-native API. It doesn't bypass the X server with direct rendering. It doesn't go through any other interesting mechanisms. It's there. It's a core protocol. It uses core primitives, pix maps. It works with Windows directly. No special interfaces. It is the right way to do it. The problem is currently it has limited rendering quality. The quality is lower than doing it the right way. For example, scaling down is only sample scaling nearest. So you end up with basically nasty wire effects and, it's ugly. It is mostly unaccelerated and very slow. There are exceptions to that. We can go into details. And it's still one of the things in the future. Oops. The only drivers that actually accelerate XRender are the ATI R200 or R250 and below. This is a very old and slow chip, and that's the only chipset that actually has full XRender acceleration. Nothing else does. So if you want to have it accelerated, you have to have that series of cards, which is actually relatively hard to find now because they're old. None of the closed drivers fully accelerated. NVIDIA's only accelerates one-to-one overblends, which means you take a pix map and you blend it on something else with no scaling or anything else, it'll do that. It isn't actually particularly good at it either, compared to its GL, so compared to what the actual card can do. And so far, none of the vendors who are doing drivers, like closed drivers, seem to be interested in implementing acceleration for XRender that I have seen. It has changed, it's news to me, but so far there's not a lot of it. It does require that you use certain parts of advanced chipsets generally. The 3D pipeline is better or easier to use and going to be faster. And with, as I said, with ATI and NVIDIA cards these days, no one knows how to drive them necessarily, thus not much is happening. But that means we have to do Haxfire GL to do that fancy stuff. So this is one of the reasons why I'm not playing with all these fancy things right now, because there are so many gotchas in the pipeline. And it also means a lot of people get alienated in being able to use it. Because they need particular hardware or particular drivers and particular setups. Now, E17 is backed by a lot of libraries that are actually separate, and they're shipped separately, developed kind of as a set of modular. Okay, a set of modular units that you can plug in. There's EAT, which is a really tiny thing. I called it EAT because when you link to it, it's minus LEAT. That was a joke between a few friends. It just does data storage. It's basically a zip file library with a data structure serialization bit of code attached and deserialization. So basically I say store this data structure, that's C-struct, and it serializes it to disk and it'll deserialize it back again. So loading configuration means, ooh, give me my structure back, and it gives it to me. I like that. Evis, the 2D rendering engine. There's eCore, which kind of plugs things together and provides abstractions to X, and saves you a bit of time and effort with like file operations and so on. Embryo is this nice little virtual machine which is built on small. It's actually really, really tiny. It's about double the speed of Java's JVM when it does interpretation, not just in JIT. It's a fair bit faster than Lua and all the other scripting languages by quite a margin, but it is very simple. It is not intended to be a programming language to build applications in. It's intended as a logic extension language. So it's basically C. So I can do if, then, else. If this, do a small loop, and that's about it. And Edge is an entire theme engine for doing things. And this efficiency basically means that we can do lots of fancy things that we couldn't do before. It allows us to scale down to like tiny devices, like small ARM boxes, and allows those with less money to get more enjoyment out of their investments. And it shows you care. And now it's time for demo time. I'll make this fast. Yep. How long have we got? 5? Okay, cool. And it's pants time. demo time. Let me get rid of this. So one of the things that I have over here is a media center I wrote for myself at home. I called it Rage because I was really, really upset at all the DVD manufacturers who'd insisted that I was not allowed to watch my DVDs that I'd legally bought in the US and Australia because I just happened to live in Japan. I was very unhappy about that. So I had a new policy where all my DVDs I rip to DivX and I play off disk. So this is my little media center here. And this is built using Evis and another library called Emotion, which is a front end to both Zine and GStreamer. And because it's a front end, it means I don't do the decoding, libzine and whatever it does, but this basically brings all the functioning of that into a canvas. So you can do things like just start browsing your videos. I have a little remote control that it runs. This was basically pretty much a weekend or two's hack to put together. So you can go through and watch it, and let me go find something down here in sci-fi. So actually I like pitch black. And it just works like any old video player. So you fast forward and rewind. But the fun bits come when, for example, I decided that I'd give myself impetus to fix a bit of Evis, and I thought that I would go buy myself an HD TV. So I decided to spend my Christmas bonus on a new HD TV, and now I can play full 1080p video anywhere I want, anytime. Now this is just the front end for it, and that's a 1080p video. But the real fun comes, and I'm going to use another test program I have. Oh, by the way, what you saw there playing, the reason it was a bit jerky was unfortunately it was playing that full HD TV video using software. If we decide that we're actually going to use GL, let's say, the GL engine, which is now using, it will play this and full HD video with no frame drops. It's actually going to be using about, I think about 40 to 50% CPU, and that's it. And that's on a dual core. So about 25% of CPU resources for full HD TV, which is not too bad. It's using a fragment shader to do the YUV to RGB, but that's built into Evis and you don't have to know. It's hidden behind. So the actual media player is one line of code to change that. That's why it's a command line option. And that's just the same thing. But the fun thing, oops, sorry, that was it. But then the fun bit is that now video is just an object. Let's use GL anyway. Whoops. Let's go load a few of these. Okay, S. No. Let's do T star. Oops. And this is when the fun really begins. So we decided to have a few videos with alpha blending. And all at the same time, and not dropping any frames. And the cool bit is that any of this, it doesn't matter whether I use hardware, software, GL, I can do this. And the same libraries will allow me to put this video on a desktop background, inside your title bars, menus, anywhere I like. It's just yet another object to stick somewhere. The back-end handles all of that. Whoops. Fast forward. But anyway, that's what you can do with once you actually abstract. So once you do some fancy things, by the way, also the APIs, if you're doing programming, make things incredibly easy. That code there, can everyone see it? Can everyone see that? That is a DVD player or a video player. That's the entire code base. You don't need any more. I'm fairly minimalist. You can't actually fast forward or rewind or anything else. But that is an entire video player in a single app. So that's how easy it gets. And you know most of it is just setting up parameters as to what you want to do. Actual code is really easy. I've got actually add a little tutorial on how to do this. And one last thing. Oh, and by the way, this here is Enlightenment running in the background. So if I, whoops, I don't have multiple windows here. This is it being in action. You can do normal alt tab around the place. And oh yeah, and other small bonuses. So,
What was that about only using animation?
Oh yeah, as I said, only use it when you should. I do think my desktop background has this on it. This is merely a tech demo of what's possible. But you know, when I feel like it, give myself a few animated the backgrounds, and that's actually animating it 2 places, and fade my backgrounds in from each other when you change. And if I really want to, it'll have, you know, this desktop has this, and let's go to another desktop, and this one might have this. So now, and so that, yeah, etc. But the main point is that all the optimizations have been done to make that possible and make it really easy. And there's a lot more to this. You really have to spend time playing with it. Little file manager there. So I can go into my pictures, backgrounds there. And it'll have little thumbnails and so on. Anyway, that's most of the demo. I didn't get to showing the other things. Now, has anyone got any questions? I'm running close on time.
2 questions to make it quick. Hands up. No one's going. Okay.
No?
Would you say we can take E17 and use it like E16 today? Could we use E17 today like we're using E16? Would you say it's ready enough for us to use?
I use it every day.
That's not my question.
There's a lot of people who use it day in, day out. A lot of them will swear by it that it's probably more stable than E16 and it's more usable. I personally am being conservative, but what people say is it's probably more stable than most release software from CVS. So if that tells you what it is, but I have my standards and I prefer to keep it high.
Thanks.
Yeah.
Okay. Can we all thank Rasta in the normal way?